Hello, this is Dr. Mears. Today I promised you that I would go over our Logic Formative 2. This was the second formative of our Logic little mini unit we have. And so I'm just going to go through them, write down the answers, almost think out loud of how I would go about solving the problem so you could see the train of thought and what goes on in my head as I'm doing these. So hopefully that will help you complete some of your logic work as well. So here we go. I'm going to read it first. In a particular school, students must choose at least one of three optional subjects: art, psychology, or history. Consider the following propositions. So A is I choose a trip. B is I choose psychology. And, sorry, P, A, B, A, P, and H is I choose history. Our directions say write in words the compound proposition. So here we have not, if not H, then P or A. So we have to first do this in order, and second, make sure that we have our connectives correct. So first is H. I'm going to go to H. I choose history, and we need to negate that. So since this is an if-then, I'm going to write if I do not choose history, comma, then. So here is my not. Here's my choosing history. Here's my then. Let's do our P or A. And so this or here is one or the other or both. And so this is the inclusive. We have to be careful with that. So P, let's go to P, choosing psychology. Then I choose psychology. Or A is art. Or both, because remember, I'm including it. So if I do not choose history, then I choose psychology or art or both. And if we look back, it says at least one, which means we can choose one or more. So here we go. So here's not H, if not H, then P or both A. And that's what you do, writing in words. Let's go to 1B. 1B, we have to complete the following truth table. And so they set up the A and the P. They set up the negation of A. Now they want us to do if not A, then P. So now here's our connective. Our connected is our if then. The only time our if then is false is if this first one is true, this one is false. That means the entire thing is also false. That's the only false that we're going to have. So let's look to see where we go first because order matters. So we go first to the not A. So I'm going to look here first. Then we go to the P. I'm going to look at the P second. So how I'm going to need to train my eyes to look at this is to go from A, not A, to P. So I'm going from here to here. So now let's remember, first one true, second one false. We automatically have a false. Anything else is always true. So let's look at not A, false, to P, true. That means it's going to be true. Here we have false, false. That's going to be true. True, true. That's going to be true. True, false. Here's that case. This is going to be false. So there's our one false here. Let's answer the question. 1C, state whether if not A, then P is a tautology, a contradiction, or neither. Justify your answer. So a tautology would be, for this one, we go and locate that column. A tautology would be if these were all true, and they're not. We have a false. Okay, so it's not a tautology. A contradiction would be if these were all, that last column was all false. We don't have all false. That's out. So it's neither. And so when we justify our answer, we have to put down that these aren't all true and these aren't all false, and that's why it's neither. So let's write that. Let's say neither, because the last column, and I like to name what the last column is, and that was the if not A, then P, is not all true meaning tautology, or all false, meaning a contradiction. So that's why it's neither. Neither because the last column, if not A, then P, is not all true, which would be a tautology, or not all false. Let's add that in, not all false, which is a contradiction. So you have to make sure you tell me where you're looking. Last column. Tell me what that last column is, and then tell me why it's not all true and not all false. So tell me why it's not a tautology and not a contradiction. And there's where you would get your points. Okay, let's flip it over to the second page. We have another consider the statements. We have P, the numbers X and Y are even. Q, the sum of X and Y is an even number. Write down in words the statement if P then Q. So what we have to do is we have the if order matters, P, the numbers X and Y are both even, then Q, the sum of X and Y is an even number. Now here's what I'm looking for when I grade this. I'm looking for the if then. I'm also looking for the order P and then Q. And be careful with words because it says both. So make sure that you put that down, both. So I'm looking for specific things here. Okay, next, write down in words the inverse of the statement P, if P, then Q. So the inverse is when we negate both parts. So what we have to really do is do not P, if not P, then not Q. And I like to write down what the inverse is because it helps to give me a visual of what to do with these. So for P, we're going to put in are not both even and is not an even number. Now, our not evens, you can substitute the word odd, which is fine. I'm going to write it down and then I'll show you how I substitute. So if the numbers X and Y are not both even, and again, you can substitute if you're not both even, you may put the word odd in for these. You can do that. I will accept that. Then the sum is not an even number. So here the word odd can go, and here the word odd can go as well. So even if you read this, if the numbers X and Y are odd, then the sum is odd. You can read it like that as well. And I put these in parentheses just to remind myself that they could be odd and that I would accept those as answers on your paper as well. So there's your inverse. The next part, state whether the inverse of the statement, so state whether the inverse, so we're going to be looking back at this sentence, is always true. Justify your answer. Now here's the thing. Our inverse, not P, if not P, then not Q. It's going to be false, remember, when the first one's true and the second one is false, that's when it's false. That's when we disprove this. So what we want to do is, I gave you a hint, provide two numbers that would make this false. So we want to provide a counter example, one that makes it false. And so remember, if this first one's true, this one's false, that means that we have made it false, that it's not always true. So let's see what we can do. So the first part has to be true. So let's go to the first part up here. If the numbers X and Y are not both even, so meaning odd. So think of two odd numbers. I'm going to think of two odd numbers. Let's see, 3 and 5. Those are two odd numbers. I wrote them down. Okay. Now what we have to do is find the sum. It says then the sum. Sum is when we add. So let's add these together. So I'm going to do odd plus odd here equals, write down 3 plus 5 is 8. And so we're going to equal an even number. And so let's look to see if it was true, this would be an odd number. What did I get? I got even. So the first part was true. The second part was false because this should have been odd like it says up here, which means I just totally made this false. So we proved that it can't always be true. How are we going to write that up? We can say, okay, if two odd numbers are added together, such as 3 and 5, our sum is even. We can even put then. Then our sum is even. This provides a false statement. So not always true. There we go. And we can even say put a little 8 here if you want. I always love to justify my reasoning. So if if two odd numbers are added together, such as 3 and 5, then our sum is even, 8. This provides a false statement, so it's not always true. So there you go. So sometimes a counterexample such as this helps us to say that it's not going to always be true. All right, next page, number 3. I provide you with the truth table. We need to complete it. So the first one we see we have P, we have Q. We need to do not P, the negation. So we're going to look at this and we're going to take the negation. Negation of true is false, true is false, false is true, false is true. Okay, next we're going to look at P and then we're going to look at Q. We have an and as a connective. So we're going to go from P to Q, so from 1 to 2. So here's where I'm looking. This is what I need to train my eyes, so from here to here. Okay, now and is going to say the only time it's going to be true for an and is when both of these are true, then it's always going to be true. Anything else, it's going to be false. So let's look. True and true, what did we just say? That's the only true. Perfect. True and false, can't have it. False and true, can't have it. False and false, can't have it. So here is our truth table for P and Q. Now let's do not P, number 1, or exclusive because it has this line underneath, Q. So we're going to now do, and I'm going to put my little ones down here. So we're going to go from 1 over to 2. So we have to go this way. So we're going backwards. So we're going to look at these two columns, but I need to start here first. We have the connective of or exclusive. So that means that I can have one or the other. That's it. One or the other. I cannot have both true. I cannot have both false. One or the other. So let's look. So one or the other will be true. One or the other will be true. And so these are the only times that those will be true. All right, so let's look. Remember, we're going from not P to Q, not P to Q. So we're going from false to true. I can have that. False to false. I cannot have that. True to true. I cannot have that. And true to false. I can have that. I also need some lights in here, so give me a second. There we go. Okay, and I'm back. All right, next. Now what we're going to be doing is we're going to be connecting these two. Let's see who's first. First is P and Q. If P and Q, then here's our connective, not P or not Q, number 2. So we're going to be going from P and Q, 1, looking over to here to 2. So we're going to be going this way from here to here because that's what this tells us. And we're going to be looking at the if then. Now remember, if then, the only time it's false is when this is true, the first one, and the second one is false. That's when we'll get our false. Regardless, everything else is going to be true. So let's look. We're going from here to here. True and true. Can we have that? Yes. False and false. Can we have that? Yes. False and false. Can we have that? Yes. False, then true. Can we have that? Yes. This situation didn't come up, so we're good. We look, we see all true. I bet you the next question is going to be about a tautology, don't you? State whether the statement, if P and Q, then not P or Q, exclusive, is a local contradiction, tautology, or neither. You guessed it, our last column is all true. So, yes, it is a tautology. Actually, it wasn't even a yes or no question, so let's go yes, like right on. It is a tautology. Woohoo! Yay! Woo! All right, awesome. Just went crazy there, but hey, you know. So it is a tautology. Give a reason. So sometimes they'll separate these. A lot of people are writing like because up here, but you can write sometimes read the next one to make sure, because this is where we're going to actually put our why is it a tautology. So let's write about it. Our last column, and writing our last column, which was this guy, this right here. So I like to label that. Is all true. Making the statement a tautology. Yay! There you go. Okay. Last one, number 4. All right. First, complete the truth table below. We have P. We have Q. We now need not Q, so let's negate Q. True, false, false, true, true, false, false, true. Awesome. What's next? If P, then not Q. If then, the only time it's false is when the first one true and the second one is false. We're going from P to not Q to not Q. So we're jumping. So train our eyes. We're jumping. We don't need that middle one. Okay, we're going from here to here. So the only time that it's going to be false is when from P to not Q, is when this one is going to be true, this one is going to be false, that's when it's going to be false. So here we go. True, false. What happens? We have that. It's false. True, true, we can, fine. False, false, fine. False, true, fine. So here we have that false, everything else is true. Okay, let's do not P. So we're going to look at P. Let's negate false, false, true, true. What's next? If not P, then Q. So again, this one has to be true, that one has to be false for the whole thing to be false. Let's see where we're going. We're going from not P all the way over here to Q. This is number 2. So I don't need these middle ones. I'm going from here to here, this way, this way. Okay, so here's what I'm looking for it to be false. So these two are out. Let's go. False, true, absolutely fine. False, false, absolutely fine. True, true, absolutely fine. True, false, we can't have that. That's false. That's this condition up here. So here we have true, 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 false. Next, decide whether the compound proposition, if P, then not Q, is logically equivalent to if not P, then Q. So we don't have that here. We don't have that column here. So what we're going to need to do, this is an extension question because we're going to have to extend that. We have this one, if not P, then Q, not Q. If P, then not Q, sorry. So we have that one's right here. This would be our number 1. P, then not Q. Double arrow to not P, then Q. Sorry, a little squished. So we're actually going from here all the way over to here. So we have those two from here to over here. We have them, but we don't have the extension on the table, so we have to make it. So let's see. We want to find out if it's a tautology, so we're looking for this last column to be true. So let's see what happens. Now this is a double arrow. Double arrows mean they both have to be true or both have to be false to be true. Otherwise, everything else is false. So let's look. We're going from here to here. So we have false, we have true, we can't have that, that's false. Oh, am I looking at the right one? I think I'm looking at the right one. Yes, looking at the right one. False, true. Yes, am I going the correct way? Perfect. Okay, just wanted to check. True, true, we can have that, that's true. True, true, we can have that, that's true. True, false, we can't have that, that's false. So let's go back. Is it a tautology? Do we have all trues in this last column that we added on? No. We see that we have a false here and a false here. So if this was going to be a tautology, what we would need is we would need for our fourth column, 1, 2, 3, fourth column, and our sixth column to be the same. They would have to be both false or both true. So the fourth column and the sixth column would need to be the exact same for each spot. That's when it would come out all true. So that's actually what I'm going to state. So you can say the last column I added on and you can name it. Is not all true. Therefore, the compound preposition you can also, so that's the original statement. We've been saying that our last columns are not all true. Let's go further with our reasoning, and let's say the fourth column, which was the if P then not Q, and the sixth column, which was not P then Q, would need to be the exact same. For a tautology. Here is your 8 answer. Sorry, it's a little squished. So here is your 8 answer because I not only said what I added, what would happen if I added the last column, and I didn't only just say that, that would have to be true. I also showed location where the fourth column and the sixth column, they would need to be the exact same because the only way we can have a logical equivalent is if they're both true or both false. So they would have to have the same exact answers. So I went above and beyond answering this question. So this would get you your 8. I hope this helped. It was a little bit long. Hopefully either you paused it and were able to understand my thinking and then tried it on your own. If not, I would try this again on your own and see. So good luck. Hope this helped. Dr. Mears signing out.